Hello and welcome to this video lesson. This video lesson is on compound angle and double angle formulas. We're going to start off with the unit circle, and we're going to have our x-axis, the y-axis. We're going to have two terminal arms. The first one is going to correspond to angle A, and the second one is going to correspond to angle A plus B, thus making point P here with OC being cosine of A plus B and PC being sine of A plus B. From point P here, we're going to draw a perpendicular line to our first terminal arm, and we are going to draw a and we're going to label this Q, and we're going to draw a perpendicular line from here to the x-axis, and we're going to draw a perpendicular line also to PC over here, so that length RQ is going to equal to CD, and length RC is going to equal to QD. We know that this angle and this angle are the same using alternate angle rules because these two are actually parallel. So I can write that angle OQR is equal to angle QOD, which is also equal to A using alternate angle. And since this angle over here is equal to pi over 2 minus A, so let's write that down. So since angle RQP is equal to pi over 2 minus A, therefore, this angle over here is going to equal to, let's write that down, angle RPQ is equal to pi minus pi over 2, which is the right angle, minus that angle that I just showed you. And if we simplify this, we will get A. And therefore, we can see that this angle and this angle are actually the exact same thing. Let's write down a few information about our triangle here. We know that it's a 90-degree here, and we know that this hypotenuse is 1. And because of that, we can write down that PQ is equal to sine of B, and OQ is equal to cosine of B. And the reason for that is PQ over here, PQ, which is opposite to B, over the hypotenuse is equal to sine B, so that makes PQ is equal to sine B, and the adjacent side divided by 1 is equal to cos B, and that's what gives us that. Okay, our goal now is to find the cosine of A plus B, which is this length over here. And to find that, we need two sets of information. We need to figure out what this length over here is. So I'm going to highlight that using a color green. And we need to figure out what this length is, and then just subtract the two. And we know that length CD is also equal to this length over here. Now, we're going to use two different triangles here, this triangle and this triangle. And we're going to use this one to find a ratio that defines OD. And we know that cosine of A is going to equal to OD, which is the adjacent side over OQ. So let's just write that down. So we know that cosine of A is equal to OD over OQ, which makes OD equal to cosine of A multiplied by OQ. But we know that OQ is equal to cos B. We just found that out right here. And I will highlight this as green so you can kind of correspond to which length we're looking at. The next thing we're going to do is we're going to figure out what length RQ is, and that's same as CD, so then we can easily subtract them. And this length is simply, we can figure out that this is sine of A, and sine of A is opposite, which is this length, over the hypotenuse, which is PQ. We already have PQ as sine B, so that will make everything much easier. So we know that sine A in the triangle above is equal to RQ over PQ, and that makes RQ is equal to PQ times, or sine A multiplied by PQ, and PQ is just sine of B. Now I will highlight RQ and RQ so you can kind of see how it corresponds. Now, as we said before, cosine of A plus B is equal to length OC, and that's because it's a unit circle. And OC is equal to length OD minus CD. And we know that CD is also same as RQ. And now we can plug everything in. So we know that OD is equal to cosine of A cosine of B. And we know that RQ is equal to sine of A and sine of B. And this will give us the identity that cosine of A plus B is equal to cosine A cosine B minus sine of A sine of B. Now, we can let B equal to negative B. And if we do that, we can just plug it into the equation, and we get cosine of A minus B, because it's A plus minus B, is equal to cosine of A cosine of negative B minus sine of A sine of negative B. Now, since sine of negative B is equal to negative sine B, and cosine of negative B is equal to cosine of B, and you can figure this out just looking at a unit circle, we can say that we got cosine of negative B is just cosine of B, and sine of negative B is equal to negative sine B, and negative make it positive, and this makes this sine A sine B. And this is our second identity. We are going to use a very similar idea to come up with the identity for compound angles for the sine. And this is what we're looking at, sine of A plus B. So we need this length over here, and we need this length over here. So I'm going to highlight them using different colors. I'm going to highlight this one as green, and these two lengths are the same. And I'm going to highlight this one as yellow. Just like before, PQ is equal to sine B, and OQ is equal to cosine of B. Now, looking at this triangle over here, I know that this is the opposite side to angle A, so using trig ratios, I can write that sine of A is equal to QD over the hypotenuse, which is OQ, and this will give us QD is equal to sine A OQ, and we know that OQ is the same as cosine of B, which is written right here. And I am just going to highlight this in green so you can see the corresponding side in the shape. Now we will use this triangle over here to find this side over here. We know that this side is adjacent to this right angle triangle. Therefore, cosine of A is going to equal to, so cosine of A is going to equal to the adjacent side, which is PR, over the hypotenuse, which is PQ. And this will give us PR is equal to cosine, or just PQ multiplied by cosine of A, and PQ is same as sine B. So we can write it like this. And I'm just going to highlight this so you can find a corresponding side within the figure. Now, sine of A plus B is equal to these two lengths added, so I can write this as P. We know that it's equal to PC, and PC is equal to RC plus PR. And RC is same as QD in terms of length. So we can write that, and we know what QD is. It's equal to sine A cosine B, and we know what PR is. PR is equal to sine B cosine A. And we can see that this is our identity for compound angle of sine. And I'm just going to highlight these so you can see it a little bit easier within the diagram. Now, similar to last time, if I set let b equal to negative b, I can just plug everything in. Sine of a plus negative b is equal to sine of a cosine of negative b plus sine of negative b cosine of a. So therefore, I forgot a bracket there, sine of a minus b is equal to sine of a cosine of b, and since sine of negative b is negative sine b, this would be our identity. To summarize our equations over here, so sine of a plus or minus b is going to equal to sine a cosine of b plus or minus cosine of a sine of b, and cosine of a plus or minus b is going to equal to cosine of a cosine of b minus plus sine of a sine of b. Therefore, if you're trying to find cosine of a plus b, you're going to use the minus. A minus b, you're going to use the plus here. And plus, plus, minus, minus. Now let's derive what tan of a plus b would be. And we know that tan of a plus b is sine of a plus b over cosine of a plus b, which means this is sine a cosine b plus cosine a sine b, all divided by cosine a cosine b minus sine a sine b. Now we're going to do something interesting. We're going to divide every term by cosine A cosine B. And we can do this because we're doing it to every single term. And we'll start getting a few things canceling out. So these two are going to cancel out. Cos A's are going to cancel out here. The whole thing is going to cancel out, leave us with 1. And this one, nothing is going to cancel out there. So to write our final answer, sine A over cos A is tan A. Sine B over cos B is tan B. And we got 1 minus tan A tan B. Now we can do the exact same thing for tan of A minus B, and I'm not going to write everything down. Get the exact same idea, except that numerator will become minus tan B, and the denominator becomes 1 plus tan A tan B. And you can try this at home and you should get the exact same thing. Or you can do you can use another method of just using negative b instead and plug it in, and you should get the exact same thing as this. And to summarize this one, I'm just going to write it down here. We have tan of a plus or minus b is equal to tan a plus or minus tan b, and 1 minus plus tan a tan b. And these are our formulas over here. So we got this one for tan, we got this one for cos, and we got this one for sine. Now we're going to use compound angle formulas to come up with double angle formulas for our identities. So first one is sine of 2a is same as sine of a plus a. And using our formula, we get sine a cos a plus cos a sine a. And since these two are the same, this is simply equal to 2 sine a cos a. And this is our double angle identity for sine of 2a. For cosine of 2a, this is equal to cosine of a plus a. And if we put in our equation, we get cos a minus sine a sine a, which basically means cos squared a minus sine squared a. Now we can go further and change cosine squared a to 1 minus sine squared a minus sine squared a, and this would give us 1 minus 2 sine squared a. Similarly, we can also write it as cos squared a minus 1 minus cos squared a, and we get cos squared a minus 1 plus cos squared a, which is same as 2 cos squared a minus 1. And these are the three identities for cosine of 2a. For tan of 2a, we can write this as tan of a plus a, which is tan of a plus tan of a, and here 1 minus tan of a multiplied by tan of a, and this one simplifies to 2 tan a over 1 minus tan squared a. And this is our identity for tan of 2a. Okay, let's look at one example here. Here we're asked to find the exact value of cosine of pi over 8. And pi over 8 is not a special angle, so we can't really know what the value is, but we know that pi over 8 is related to a special angle of pi over 4, and we know that 2 times pi over 8 will equal to pi over 4, which is an angle for which we know the cos value for. So let's use, because we have 2 times pi over 8, why not try to use the double angle identity? So we know that cosine of 2a is equal to 2 cos squared a minus 1. And this is good because cosine of 2a would be cosine of pi over 4, so we know the value of that. And here we're left with cosine squared of pi over 8, when we can isolate for that and actually calculate the value. So isolating for cosine squared a, we get 2 cos squared a is equal to cosine of 2a, and I should put the brackets, plus 1. And cos squared a is equal to cosine of 2a plus 1 over 2. And now I can just plug in my values. I'm trying to find cosine squared of pi over 8 here, and that's equal to cosine of 2 times a, which is pi over 4, plus 1, divided by 2. Cosine of pi over 4 is root 2 over 2, plus 1 over 2. I'm just going to simplify this, and I get root 2 plus 2 over 4. And I'm going to take the square root of both sides, and I get cosine of pi over 8 is equal to plus or minus square root of root 2 plus 2 over 4. And since cosine of pi, well, since angle pi over 8 is in quadrant 1, therefore it needs to be positive only, it can't be negative. And if I simplify this, cosine of pi over 8 will equal to only the positive. The top would be the square root of, I'm just going to change the order, over square root of 4, which is value of 2. And that would be my final answer. Now, let's do another example. This time we're asked to find the exact value of sine of 75 degrees. We're looking for exact value, so we need to kind of figure out what that is in special angles. 75 is not a special angle. However, sine of 75 can be written as sine of 45 plus 30, both of which are special angles. This here will equal to sine of 45 cosine of 30 plus cosine of 45 and sine of 30. We know that sine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2. Cosine of 45 is root 2 over 2. And sine of 30 is 1 over 2. Now we can multiply these together. We would get root 6 over 4 plus root 2 over 4, and that's root 6 plus root 2 over 4.